All right, thanks for clicking on this video. Grab some paper, grab something to write with, maybe a calculator, and follow along with me as we go through the 2023 ICTM Regional A Algebra 2 contest. Don't forget the timestamps are below if there's a particular problem that you want to jump to. So with number 1, let k equal log 20 of 3. So find the value of k. Now we want to express your answer as a decimal. So this is important. When I do these problems, I always underline this phrase to remind myself, okay, this is a problem that I'm going to be using my calculator and I'm going to write as a decimal. So the normal rules of fractions and radicals obviously don't apply here. So if I want log base 20 of 23, that's equal to, the change of base rule says you take log 23 over log 20. So I get out my calculator, so log 23, and then I divide that by log 20, and we get 1.406653, and I can stop there because we want it rounded to the nearest thousandth, so that's 1.407. So there is the answer to number 1. Number 2. Let I equal the square root of -1. They always are going to define that for you. And then let I to the 20th to the 23rd equals a plus bi for real numbers a and b. We want to determine the ordered pairs a and b. Now, if you have a graphing calculator, this can actually do this. I have I, and I can raise that to the 20th. And then I take all of that to the 23rd, and that's equal to 1. So I to the 20th equals 1. So 1 to the 23rd power equals 1, but I want it in this form. So that means it's 1 plus 0i, where 1 is a and 0 is b. So my guess is a lot of people probably got this wrong because they just said 1 when they should have written it as the ordered pair 1, 0. All right, next one. Determine the value of k when this statement is true. Okay, so with matrix multiplication, the way I arrive at 1 is I multiply these two numbers times these two numbers in that order. So 5 times 1, 4 times -1, put them together, and we get 1. Now if I move this, whoops. So now, whoops. If I move that down to here and multiply these two, 1 times 1 and 1 times -1, so we get 1 and -1 adds up to 0. That gives me this. That's because I multiply the second row by the first column, so that's what my result is. So if I'm concerned with letter K, what I'm going to do, let's erase these. I'm going to multiply, whoops, highlighter, these two. So I multiply first times first, so 5k. So 5k plus 5 times 4. So I'm multiplying the first row, the second column, and that's telling me that that equals 0. So that means 5k plus 20 equals 0. So 5k equals -20. We divide by 5. K is equal to -4. And there's our answer. Number 4. Let y vary directly as k and inversely as the square of z. So with this information, we have y equals k times x divided by z squared. Now from there, we're going to use this information to figure out the value of k. So 2 equals k times, in place of x, we put 3 times 4 squared. So 2 equals 3 over 16k. So when I multiply over the 16, we get 32 equals 3k. And then we divide by 3, 32 over 3 equals k. Now that's not our answer though, because we want to determine the value of y when x is 9 and z is 2, but now we have to use this value of k. So y equals 32 over 3 times x is 9, that's on top, over 2 squared. So 32 over 3 times 9 over 4. We can do a little canceling. Cancel out, be left with 1 and 3. And we'll cancel these out, be left with 1 and 8. So all in all, we're left with 8 times 3 and 1 on the bottom. So that means for number 4, our answer is 24. Number 5, let log 6 of 2 equals a. Then in terms of a, log 6 of 4 over 9 equals k a plus w. So we want to determine these ordered pairs. Now, the temptation would be to say, well, I look at log 6. I'm going to ignore that for the moment. Log 6 of 4 over 9 equals log 6 of 4 minus log 6 of 9. So far, so good, right? Well, because I can do log 6 of 2 squared, log 6 of 3 squared. So I have 2 log 6 of 2 minus 2 log 6 of 3, and this right here is a. So 2a minus 2 log 6 of 3. Now, notice that what it says. Notice that k and w are integers. Well, this is k, at least for this part it would be, but then this is not going to be an integer. So what we have to do is we have to go all the way back to the beginning and rethink this problem. Because all we can do is we can pull out either powers of 2 or powers of 6. That's all we can do. So what I'm going to do is log 6 of, so we have 4/9. So inside I'm going to multiply 4 over 4. So we have log 6 of 16 over 36. Now, you may be asking, how does that change things? Well, if I follow the same steps, log 6 of 16 minus log 6 of 36, I can write 16, log 6, as 2 to the 4th, and I can write 36 as log 6 of 6 squared. And now I can bring out those powers out in front using that property of logs. 4 log 6 of 2 minus 2 log 6 of 6. Now this right here, log 6 of 2, this is a. And this right here, log 6 of 6, is 1. So we have 4a minus 2. So that means our ordered pair is 4 comma negative 2. Notice here that it's plus w, but down here it's minus 2. So that means we have to include the negative 2 in our answer. Number 6. So here we want this whole thing as a common or an improper fraction. Well, let's see what our calculator can do with this. Now I think I can save myself a little bit of time. 1 to any power is going to be 1. So that's 1. And anything to the 0 power, like this, is going to be 1. So let's take 8 raised to the negative 5 over 3. And let's turn that into a fraction. So that's minus 1 over 32. Next, we have 4 over 9 raised to the negative 3 halves. Oops, get rid of that. Delete that. All right, make it a fraction. So plus 27 over 8 minus Now we'll do this. So 4 raised to the 3/2 is 8 plus. All right. And then 2 to the 5th divided by 5 squared minus 2 squared. And then we'll flip that, and then we'll make that a fraction. So that's 21 over 32. Okay, so now things are a little more simplified. So now using my calculator, we'll combine these. So 1 minus 1 over 32 plus 27 over 8 plus 1 minus 8 plus 21 over 32. And after all of that, we get negative 2. All right, number 7. The 8th term of this sequence can be written as a plus b square root of 2. So we want to determine the ordered pair. Now this one actually has 2 answers because some people realize that this could be a geometric sequence. And so what happens is you start with the first term, 1 plus square root of 2. That's a 1. And then the second term is square root of 2 plus 2. And you get that by multiplying by square root of 2 by square root of 2 to get the second term. And then if you do it again, you get 2 plus 2 square root of 2. So if you treated this as a geometric sequence, not an arithmetic, but a geometric sequence, what you do is we want the 8th term. That's what we want. So A8 equals A1 times R to the 8 minus 1. Now the first term is 1 plus square root of 2, and the common ratio, square root of 2 to the 7th. So 1 plus square root of 2. All right. Now square root of 2, I'm going to break that up. Square root of 2 to the 6th power, and leave that extra square root of 2. So you have 1 plus square root of 2. Now square root of 2 raised to the 6th power. So square root of 2 to the 6th, that gives us 8. And then we still have that extra square root of 2 left behind. So now if I multiply square root of 2 onto these, so we get square root of 2 plus 2, and then we multiply by 8. Now it can be written as a plus b square root of 2, so that means we start with 16 plus 8 square root of 2. So that means we get 16 comma 8 as one possible answer. The other possible answer, all right, so if I go back up top, the idea was that from here to here, we added 1. We just kept square root of 2 as it was, we just added 1. But then we added another square root of 2. And so what we're doing here is we're doing 2 alternate rules, plus 1, and then plus square root of 2 each time. So if we want the 8th term, that means we're going to add 1 4 times, and we're going to add square root of 2 3 times. In which case, we would get 5 plus 4 square root of 2. So 5 comma 4 is the other possible answer. Number 8. The rate at which Dan drives his car is 1.5 times the rate at which Rob drives his truck. Now Dan leaves the gas station 40 minutes after Rob left the same station. Both drive nonstop along the same route. Dan overtakes Rob in 100 miles. So determine the rate of Rob's truck in miles per hour. All right, so this is a distance equals rate times time. Okay, so we've got Dan and we've got Rob. Now what we want is the rate of Rob's truck. So that right there is our variable. Now they both travel 100 miles. Now what we don't know is we don't know the time. So I'm just going to call this T. Now for Dan, he traveled 40 minutes less. So this is T minus 100. Now, it says the rate at which Dan drives his car is 1.5 times the rate which Rob drives his truck. So I can say 1.5x. So, if I were to take this and write out this equation, this would be 100 equals 1.5x times t minus 100. So we have 1.5 xt minus 150x. If I take this equation, this is a little simpler. 100 equals xt. Important thing is that both of these equations equal 100. So since they both equal 100, they can equal each other. So xt equals 1.5 xt minus 150x. So from here, what we can do is we can divide x out of everything. And what we're left with is t equals 1.5 t minus 150 t. Whoops. Let me go back. Made one little mistake. That should not be 100. That should have been 40. So, my mistake. Let's fix that. 60x. All right, 60 minus 60. There we go. Okay, back on track. So negative 0.5 t equals negative 60. So that means t is equal to 120. Now, this is going to be in minutes. Now, how do I know that? Because when I subtracted 40, that was 40 minutes. So the time, that's the time that it took Rob, was 20 minutes. So for Rob, that was 2 hours. So to get his rate, x equals 100 over 2. So that means 50 miles per hour. So that's how we get our answer of 50. Number 9. Here we have two functions. F of x equals 20x plus 4. G is given by 23x minus 10. So what is the value of f of g of 2? So we start with g of 2. So we're going to substitute 2 in for x. So 23 times 2, that's going to be 46 minus 10 equals 36. So now we want f of this number, f of 36. So 20 times 36 plus 4. Oops. Calculator. 20 times 36 plus 4. So that gives us our answer of 724. Number 10. One of the real roots is the square of the other root. So we want to determine the value of k. So that means if I were to factor this, we'd have x minus a, x minus b. But it says one root is the square of the other. So I could write x minus a and x minus a squared. And if I were to FOIL this, I'd have x squared minus a squared x minus ax plus a cubed equals 0. Now, important thing here, this right here, this term is 8. So a cubed is 8. So that means a equals 2, which means b is equal to 4. So we want to determine the value of k. Well, we would get k from the x term, from those two. So negative 2, in order, it would be negative 4x minus 2x. So that means we have negative 6x. Notice that there's already a negative accounted for. So the answer is not negative 6. The answer is just 6. Number 11. When x plus y to the nth is expanded and completely simplified in decreasing order, the coefficients of the fifth and sixth terms are equal. So we want to determine the third term of this expansion. So this is involving the binomial theorem. Now we start with, some people are going to write it as n over 0 like that, and some people are going to write it with combination notation. It works the same either way. But basically what they're saying is the fifth and sixth terms are going to be equal. So nc0, nc1, nc2, nc3, nc4, nc5, nc6. Now they say the fifth and sixth, so 1, 2, 3, 4, 5, 6. So that means these two are equal. Now that right there tells us that our middle is right here. So there's an equal number of these before this dotted line as there are after. So let's see, 0, 1, 2, 3, 4. Now if I count backwards, 5, 6, 7, 8, 9. So for this problem, n is equal to 9. Now we want to determine the coefficient of the third term of this expansion. Now the third term is going to be that. So 9c2. So we have 9c2. Whoops. So 9c. All right, so 9. Let's fix that. Calculator is 36. Number 12, the graph of y equals 2/5 and y equals x squared times x minus 1 quantity squared times x plus 2 quantity squared meet at k distinct points. So we want the value. This is a straight up calculator question. So x squared times x minus 1 squared times x plus 2 squared. Okay, now notice I'm concerned about when it hits around 2/5. So for my window, 2/5 is 0.4. So I'm going to go from 0.2 to 0.6. And I'm going to make my x min negative 10 and my y max positive 10. And let's see. Okay. Looks like we've got several. Now, this spot right there, I'm not quite sure about. So I need to get in real close to be absolutely sure whether or not they touch. And it looks like it doesn't. It looks like it comes up, but comes just short of that. So let me go in even further. Yep. All I see are 1, 2, 3, 4 distinct points. Because that other point, it comes up short, but comes down. And if you have it at a zoom standard or a zoom decimal, it'll look like it when it's pixelated, like that it touches, but it actually doesn't. Number 13, determine the value of x only when this equals that and x does not equal negative 13 over 6 y. Okay, so we need to take these two and we need to factor them. So for the top, I'm not even going to look at this part for right now. I'm just going to look at the top. And I see 42x squared. I can break that into 6x and 7x. And 65y squared, I can break that into 5y and 13y. Now what I need is I need to get the middle term of 61. So let's see, 6 times 13 is 78. 5 times 7 is 35. If I subtract them, I do not get 61. So what happens if I flipped them? So what if I put 13y over here and 5y over here? So 7 times 13 and 6 times 5. This is looking promising. 91 minus 30. There we go. There's 61. Now I want 61 to be positive, so that means this should be plus and this should be minus. Okay, so now down here, I notice that 36 and 169 are squares. So that leads me to suspect that this is 6x and 6x, and this is 13y and 13y. So let's check that middle term, see if we're right. So 6 times 13 plus 6 times 13, yep, 156. And what do you know? We have this completely cancel away. So what we're left with is we're left with 7x minus 5y over 6x plus 13. That's what this term on the left is. So now let's take away what I covered up. Now this is equal to 51 minus 15y over 18x plus 39y. Now, I think I can factor something out because 15 is divisible by 3 and so is 51. Because I know 15, I can take 3 out and be left with 5y. 51, we get 17. And I know I can factor a 3 out of the bottom, left with 6x plus 13y. So we have 17 minus 5y over 6x plus 13y, but that's equal to the same denominator as what we had already. And they already said that x does not equal negative 13 over 6y. That gives us the freedom to cancel that denominator away and just focus on the numerators. 7x minus 5y equals 17 minus 5y. Hey, wait a minute. I've got a minus 5y on both sides. If I add that, it's just going to go away. So 7x equals 17 divided by 7, and x equals 17 over 7. Number 14, determine the values for k when 3 to the 2k plus 2 equals 1 equals 6 times 3 to the k. Now what I'm going to do is I'm going to break this apart. 6 times 3 to the k. All right. Now, 3 squared is 9 times. Now instead of 3 to the 2k, I'm going to write this as 3k squared plus 1 equals 6 times 3 to the k. Now what we have is we have the same thing here and here. So I'm going to substitute y in place of that. And what we see is that we have a quadratic. So I'm going to subtract the 6y to the other side. And now I can factor this So we have 3y minus 1. So that means we're only going to have one real solution. So 3y equals 1, y equals 1/3. But we don't want to solve for x, we want to solve for k. And so k is part of 3 to the k, which is what 1/3 is equal to. So 3 to the k equals 1/3. And 1/3 is just 3 raised to the negative 1 power. So that means that k is equal to negative 1. Number 15, limousine shuttle service operating between a hotel and a convention location charges a fare of $10 for each passenger and carries 300 passengers per day. The company plans to raise the fare and estimates that the number of rides will decrease by 15 passengers per day for each increase of $1 in fare. Determine the most profitable new fare to charge for service. Okay. Now, most profitable is determined by how much total profit. So we have the fare, then we have the passengers, and then we have total fares. Now we start with a fare of $10 and $300 for 3,000. Now they're going to increase the fare by $1, so the fare becomes 11, but they're going to lose 15 passengers. So it's 285. And if they do that, they actually go up. They actually make more money. So the question is, how much should it go up? Now what I'm going to do is I'm going to use my calculator. I'm going to show you how I would do this, save myself a little bit of time. I'm going to write a formula for the fare. Let's say x is the number of fare increases. That means that my fare as a formula is going to be 10 plus x. However many times I raise the fare, it's only going to be $1 each time. Now for the passengers, I started with 300, but then I subtract 15 every time. Now with the total fare, I just multiplied them. Now there's no point in foiling this because the calculator is going to do that work for me. So I'm going to write 10 plus x in y1, 300 minus 15x in y2, and then 10 plus x, and 300 minus 15x. 15x. And then I'm going to use my table feature. So I'm going to start my table at 1. Go to auto. Okay. Now, as I scroll down, I can see that my fees go up, my total fees go up, but then they start to go down. Because even though I'm raising the fees, I'm losing passengers too money too fast. So that means this right here, this is my optimal situation where I make the most money. And it says determine the most profitable new fare, which is 15. Number 16, a fare coin is tossed 10 times and the head or tail facing up is recorded. Determine the probability exactly 5 heads will be recorded. Well, it's a fare coin, so that means heads is equal to 1/2, tails is equal to 1/2. Now this is a binomial probability. So that means out of 10, there's 10 C5 ways to get 5 heads. And then we multiply by the probabilities of 1/2 to the 5th times 1/2 to the 5th. So on my calculator, I go to NCR. So 10 C5 times 1/2 to the 5th times 1/2 to the 5th. And if I write that as a fraction, we get 63 over 250 6. Oops. Come on, bring it back. Okay. So number 17. For some positive values of x and y, x plus y equals 7xy, and x squared plus y squared equals 37 over 36. We want to determine the value of x plus y to the third. All right, these types of problems always mess with people. Now, the one thing I always look for is I see x squared and y squared, and then I see xy. That always sets my red flags going off a little bit to say, okay, we're solving for x plus y to the third, not x individually, not y individually. So I want to think about this. What would x plus y squared look like? Well, if I foiled that out, it would be x squared plus 2xy plus y squared. Now, we already know that x squared plus y squared is equal to 37 over 36. So I can make that replacement. Now I can also say, wait a minute, I've got xy and I've got xy right here. And so what I can do is I can use this formula to say, well, if I move the xy out of the denominator and move the 7 in, I have x plus y over 7. And this is 37 over 36 plus 2 over 7 times x plus y. Now, what does all this equal? This equals what we started with, x plus y squared. And this right here is what we're solving for. So what we're going to do is we're going to make a substitution. Y squared equals 37 over 36 plus 2/7 y. So this is going to be a quadratic formula question. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's simplify that discriminant. So 2 over 7 squared minus 4 times negative 37 over 36. And let's take the square root of that. And let's see if that's a fraction. There it is. Yes, indeed. So we have 2 over 7 plus or minus 43 over 21 all over 2. Now they said for some positive values of x and y. That means x plus y can't be negative. So if I take 2 over 7 and subtract 43 over 21, I get a negative. So I know that can't happen. All I can have is the positive value. So if I divide by 2, I get 7 over 6. Now this is what x plus y was equal to. Well, we want x plus y to the third. So that means we take 7 over 6 to the third power. And we get 343 over 216. Number 18, determine the number of arrangements of the letters in the word choice. Normally, what we would do is we would count up the number of letters, and that would be it. But we've got repeats. So we've got 2 C's. So that means we divide 6 factorial by 2 factorial to account for those repeating C's. So we've got 6 factorial, and then divided by 2 gives us 360. So with number 19, we want to determine the number of 3-digit numbers that have no zeros and have at least one 5. So let me start with the 3-digit numbers that start with 1. So here we have 115. We can't start with 105 because we can't have zeros. So the 125, 135, 185, 195. So that means there are 9 of those. Then we go 151, not 150, 152, 153, 158, 159. There are 9 zeros there. There are 9 numbers there. However, there aren't 18 numbers with a leading digit of 1 because 155 is in both of these. So that means there's actually 17 numbers. And that means there's 17 for all the 3-digit numbers that start with 1, 2, 3, 4, not 5. That's going to be different. 6, 7, 8, 9. So I'm going to multiply that by 8. And when I multiply 17 times 8, I get 136. Now, all the 3-digit numbers that start with 5 are all going to count. However, I can't just add 100 because I have to exclude the ones that have zeros. So let's list those out. 500, 501, 502, 503, up to 509. So that's 10. And then 510, 520, 530. There's 19. So I have to exclude out those 19. And when we do that, we have 136 plus 100 minus 19. And that gives us our answer of 217. Number 20. Let 1 over 2 plus 1 over 3 plus 1 over and so on equal this in simplified radical form. So we want to determine this sum. So when we have a repeated fraction, we wanted to figure out where does that repeated fraction reoccur. So this whole thing is equal to the whole thing. So x is equal to 1 over 2 plus 1 over 3 plus x. Because we're calling x the whole thing, but then that whole thing also appears right here. 1 over 2 plus 1 over 3 plus that. Okay. So now if I multiply this denominator over to the other side, I have 2x plus x over 3 plus x equals 1. So now I'm going to multiply the denominator, 3 plus x. So I have 2x times 3 plus x equals 3 plus x. So when I multiply this out, I get 6x plus 2x squared plus x equals 3 plus x. So now with a quadratic, I want to get it all on one side. So I have 2x squared on the left plus 6x, and then I'm going to subtract 3 equals 0. Now, I'm going to have to use quadratic formula to solve this. So negative 6 plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so let's see if we can expedite this a little bit. 36 minus 4 times 2 times negative 3 is 60. So negative 6, 60 over 4. All right, now 60 is not a perfect square, but I can divide out 4. So negative 6 plus or minus 2 square root of 15 over 4. So now we divide by 2, so negative 3 plus or minus square root of 15 over 2. All right, so k is the number in front. K equals negative 3. W is the number in front of the radical being multiplied. That's 1. P is the number inside the radical. That's 15. And then Q is the number in the denominator, which is 2. So now we have to add all of these together. And when we do, we get 15. Great job. We'll see you in the next video.